Hello, my name is Minko Mostrates and I'm from Ukraine. I have prepared project Study of Edible Packaging based on polysaccharides. The purpose of the study was to create and investigate edible films based on polysaccharides. To achieve this goal, it is necessary to solve following tasks. Make samples of edible films, determine the complex organoleptic index, determine the vapor permeability index, and determine the destructive tensile stress during stretching. As you know, the total mass of plastic bags in landfills worldwide is trillions of tons. Polyethylene not only pollutes the surface of the planet, but also harms its biosphere. So, developing biodegradable polymeric material is one of the most relevant areas in the current environmental situation. The importance of their development and popularization is the steady trend of replacing traditional plastics. The following requirements are imposed on edible packaging based on natural polymers. Do not contain toxic, allergenic, undigestible components. Ensure the stability of the product structure and prevent mechanical damage during transportation, storage, and processing. Protect the product from contamination. And last but not least, its production should be simple and economically feasible. Of the natural polymers for synthesizing edible packages, starch is widely used. This is due to the properties of the compound, namely, annual renewability, low cost, non-toxicity, digestibility, and excellent barrier properties to oxygen and organic aromatic substances. Starch is a mixture of polysaccharides, amylase, and amylopectin. Their chemical formulas are shown on the slide. Starch-based films' physical and mechanical properties depend on the ratio of amorphous and crystalline regions. For example, natural starches with a high amylopectin content are characterized by greater amorphousness, while starch films with a low amylopectin content are characterized by greater crystallinity. The content of amylose and amylopectin depends on the origin and age of the starch. On average, starch contains from 20 to 25% of amylose and from 75 to 80% of amylopectin. The data on the amylose content for different types of starch are given in the table on the slide. But unfortunately, it is not possible to obtain strong and non-brittle film from starch due to the peculiarities of its chemical structure. So, we decided to create films based on its mixtures with other polymers. One of these polymers is pectin. Pectins are a group of high molecular weight compounds with a high ability to gel. The gelling ability of pectin is the determining factor in its widespread use in the food industry. In our work, films with the addition of pectin, which was contained in beet juice, were studied. The films were made according to the following method. Components: water, beet juice, and starch were weighted in advance on a technical scales, following the recipe. The suspended ingredients were mixed in following sequence. Water was supplied to the reactor, then beet juice containing pectin was added, and then modified starch was added and mixed in a closed-type reactor with agitator at 90 degrees by Celsius for an hour until the solution is completely homogenized. The resulting solution was cooled to 50 degrees by Celsius, poured onto a glass substrate, and kept at room temperature for 24 hours. After that, it was carefully removed. A sample of the resulting film is shown on the slide. The formulations of the resulting films are given in the table on the slide. Vapor permeability is the primary indicator of the barrier properties of polymer packaging, which contributes to the long-term storage of the products. Our experiment aims to investigate the vapor permeability of the manufactured films and determine whether the indicator are in acceptable values. Our experiment showed that the manufactured film has a vapor permeability at about 0.5 mg per meter per hour per Pascal for all samples, which may indicate that pectin has almost no effect on vapor permeability and the starch itself determines it. The physical and mechanical characteristics of polymeric materials are determined by their structural changes in the deformation process associated with both the chemical composition and structure polymer of molecules and the mode of application of deforming forces. The resulting films are characterized by a destructive voltage at about 3 MPa. When 20% of pectin is added to the composition, the destructive stress increases to 4.3 MPa. A further increase of pectin to 30% leads to a decrease in the value of the destructive tensile stress up to 4 MPa. The study of organoleptic indicators proved that all samples have high values of these indicators regardless of the amount of pectin, so these films can be used as edible. Conclusion. The manufactured sample of film is presented on the slide. It was found that the vapor permeability of the studied films is equal to those that produced from traditional polymers under the condition of the same thickness. The study of the film's physical and mechanical properties showed that the film's thickness was about 0.6 mm and the destructive tensile stress was from 3 to 4.3 MPa depending on the formulation and is sufficient to use them as a packaging material. Thanks for your attention.